If you step outside on a clear night and look up, the stars seem equal, tiny, steady, sprinkled like dust across a vast black canvas. But the truth is, the stars that look the same from here are nothing alike. Some are so immense they could swallow entire solar systems. Others are no bigger than a planet. Some will live longer than the universe itself. And some are already burning through their final breaths while you listen to this, fading quietly into the dark. Each of those points of light is a story, and not all stories last the same length of time. Let's start with the giants. Imagine a star so large that if it replaced our sun, its edge would stretch past the orbit of Jupiter. That's not exaggeration. That's the size of a red hypergiant. One of the largest we know, UY Scuti, could fit nearly 5 billion of our suns inside it. 5 billion suns, burning together in a single body of flame. But here's the strange part. The larger a star becomes, the shorter its life. These titans live fast and die young, their cores burning fuel at a furious pace, fusing hydrogen into helium so quickly that millions of years are all they get. It sounds like a long time, but in cosmic terms, it's the lifespan of a spark. Their light is breathtaking, but brief. They shine with the power of millions of suns, yet they live only a fraction as long. They are the fireworks of the galaxy, spectacular, unforgettable, and gone almost as soon as they arrive. And then, on the other end of the spectrum, are the quiet ones, the little red dwarfs. They're small, cool, and dim, barely bright enough to see from afar, but they are patient. They burn slowly, gently, with a kind of quiet discipline. While a giant might live 10 million years, a red dwarf can live for 10 trillion, longer than the universe has existed so far. Imagine a candle that could burn for eternity because it never wastes its flame. That's what a red dwarf is. And in that difference, there's something deeply human. Some of us blaze brightly for a while and fade. Some glow softly, steadily, across vast stretches of time. Neither is better. Both are necessary. The giants create the heavy elements that smaller stars and planets depend on. The dwarfs keep their steady rhythm, holding the structure of galaxies together long after the giants have gone. The cosmos, like life itself, needs both the fireworks and the candles. Our own sun sits somewhere in between, a modest star, neither too small nor too grand. It's classified as a G-type main sequence star, which sounds plain, but that ordinariness is what allows it to last so long and stay so stable. It's the quiet, balanced kind of star that creates the perfect conditions for life. If it were larger, we'd already be dust. If it were smaller, Earth might be a frozen rock drifting in the dark. Our sun is a cosmic middle child, and its gift is endurance through moderation. It will live for around 10 billion years in total, and right now, we're only halfway through its life. When you think about it that way, all of human history has unfolded in a single heartbeat of its calm, golden rhythm. Every star, no matter its size, is a negotiation between two forces, gravity and pressure. Gravity wants to pull everything inward, collapsing the star into itself. Pressure, created by the nuclear fire within, pushes outward. The result of that perfect balance is the light we see. Too much gravity and the star implodes, too little and it fades away. In that equilibrium, that delicate middle ground, lies every sunrise you've ever seen. You can think of each star as a held breath, a moment of tension between creation and collapse. And when you realize that, starlight becomes something even more beautiful. Not just illumination, but balance made visible. Among the most striking of these luminous giants are the blue supergiants. Stars so hot, they shine in shades of white and electric blue. Their temperatures reach tens of thousands of degrees, their energy spilling across ultraviolet wavelengths our eyes can barely comprehend. If red stars are embers, blue ones are lightning. They blaze intensely and die violently, often exploding as supernovae that seed the galaxy with the heavy elements, iron, calcium, gold, that will one day form new stars, planets, and perhaps even life. Without those brilliant, brief lives, there would be no Earth, no oceans, no you. Every atom of gold in your ring, every trace of iron in your blood, was once the heart of a blue star that lived fast, died young, and gave everything it had to the universe. The giants burn out to make way for smaller lights, and the smaller lights carry their memory forward. It's the same cosmic pattern, repeating endlessly. Birth, blaze, collapse, rebirth. If you could see the universe in time-lapse, millions of years passing in a second, you'd see galaxies pulsing with this cycle of light and loss. Massive stars flaring into being, collapsing, scattering their ashes, and then watching as new stars rise from the remnants. The giants may be gone, but their dust remains. And from that dust, new worlds emerge. Even the smallest spark in the sky could be the child of a long-dead sun. And so, when you look up at night, you're not just seeing light that traveled for years or centuries. You're seeing a history of rebirth, the ghosts of long-lost giants still burning in the hearts of new ones. There's something humbling about that. The light from those massive stars began its journey before humans existed, before even Earth had continents as we know them. It traveled across space, across time, through dust and darkness until it finally touched your eyes. A tiny flicker completing a story that began long before you were born. And in that flicker is a lesson. Some lives are long, some are bright, but both are made of the same material, the same hydrogen and helium, the same energy of existence. The giants and the sparks are not opposites. They're two versions of the same song, played at different tempos. So tonight, as you drift towards sleep, think of them. The stars that live fast and the ones that endure. The brilliant, reckless blue giants and the patient, quiet red dwarfs. All of them burning for the same reason, to balance gravity and light, collapse and creation, chaos and calm. The universe needs both kinds of beauty, the fleeting and the eternal, just as we do. And perhaps, in some quiet way, every heartbeat of yours is a reflection of that same cosmic rhythm, a pulse of warmth against the pull of the void. Every star you see is doing something astonishingly simple and impossibly powerful. It's turning itself into light, not metaphorically, literally. Every second, deep inside its core, a star takes the most basic element in the universe, hydrogen, and fuses it into something heavier, releasing energy in the process. That energy becomes heat and light, and the steady pressure that keeps the star from collapsing under its own immense weight. This is the quiet heartbeat of the cosmos, the pulse of fusion that has been burning for nearly 14 billion years. If you could stand near the heart of a star, you wouldn't last even a fraction of a second. But let's imagine for a moment that you could look without being destroyed. You'd see hydrogen atoms colliding with such intensity that their individual identities begin to blur. 4 atoms merge into one helium nucleus. And in that act of union, a tiny bit of their mass disappears, converted entirely into energy. That missing piece becomes light. The glow that reaches across trillions of kilometers to touch your eyes right now is the residue of those collisions. Every ray of starlight is a record of that miracle. It's a delicate balance, a cosmic tug-of-war between gravity and pressure. Gravity, always patient, wants to pull everything inward, crushing the star into a dense, lifeless sphere. But the energy from fusion pushes outward, holding that collapse at bay. This perfect tension is what defines a star. It's not chaos, and it's not calm, it's equilibrium. You can think of it like a long, steady breath, an inhale of gravity, an exhale of fusion, repeated for billions of years. And as long as the star can keep breathing, it shines. When the breath stops, when the fuel runs out, the star begins its transformation. But for now, it glows, effortlessly, endlessly. It's strange, isn't it? The sun doesn't have to try to shine. It doesn't decide to. It just does, because that's what balance looks like on a cosmic scale. And in a quiet way, it's what life does too. You breathe, your heart beats, cells divide. Not because you force them to, but because it's the rhythm that keeps you alive. In that sense, every living thing on Earth is just a smaller version of the same principle. Balance against collapse, warmth against the void, a small flame burning against time. The universe writes the same melody again and again, just in different instruments. If you could listen to a star instead of just seeing it, you'd hear vibrations, oscillations running through its structure, like a bell ringing from the inside out. Astronomers call it asteroseismology, the study of starquakes. Every star hums a unique song, a resonance determined by its size, its density, its age. Some vibrate deep and slow, others fast and sharp. It's as if the universe is filled with a silent orchestra, millions of instruments, each playing a single note for billions of years. And the space between them is the rest in the music. The light that escapes from a star's surface travels outward for unimaginable distances. Some of it warms nearby worlds. Some of it travels for millions of years through empty space before touching a telescope lens or a human eye. And when it arrives, it tells us everything. Within that faint shimmer are clues about the star's composition, its temperature, its motion, even its age, all encoded in the color of the light. Blue stars are hot and young. Red ones are cooler and older. Yellow, like our sun, sit peacefully in between. In that color is a kind of cosmic biography, a life written in wavelength. It's easy to forget that light is more than brightness. It's information. Every photon that hits your skin tonight began its journey in the furnace of a star, perhaps millions of years ago. When you look at starlight, you're not seeing the present. You're seeing the past, preserved perfectly, still arriving. That light has traveled through dust and darkness, through cosmic storms and time itself, only to meet you now, at this exact moment. You are literally bathed in history every night, and all of it, every soft glow, every flicker, was born from that same ancient fire of fusion. But there's something even deeper hidden in that light. When stars burn, they don't just release energy, they create matter. Fusion inside their cores builds heavier and heavier elements. Hydrogen becomes helium, helium becomes carbon, carbon becomes oxygen, and so on. It's a ladder of creation, a slow, patient process that turns the simplest building blocks of the universe into everything else that exists. The carbon in your DNA, the calcium in your bones, the iron in your blood, all forged in the hearts of long-dead stars. You are literally made of starlight cooled into flesh. That fact, poetic as it sounds, is scientifically exact. Billions of years ago, massive stars lived, burned, and died, scattering their ashes into space. Those ashes drifted, coalesced, and eventually formed new stars, planets, oceans, and you. It's a cycle that repeats endlessly. Stars make atoms. Atoms make life. Life looks back and wonders where it came from. You could say that consciousness is how the universe has learned to look at itself, through the eyes of its own creations. We are the cosmos, thinking about the cosmos. And the light of the stars is the oldest part of ourselves, still reaching out across time to remind us. There's a calm kind of beauty in knowing that, because it means nothing is ever really lost. The light that leaves a star might fade from sight, but it continues on, spreading across the darkness, scattering, cooling, blending, until one day it becomes something new. A photon turns into warmth. Warmth becomes movement. Movement becomes life. And then, that life, you, me, all of us, begins to shine in its own way. So, as you drift towards sleep, imagine that quiet balance inside every star, gravity pulling inward, fusion pushing outward, neither winning, neither losing, just harmony. That same balance hums inside you too, a smaller engine of light, a personal echo of the stars. The universe doesn't just burn in distant galaxies, it breathes within you, slowly, calmly, eternally. Every star you see tonight is alive only for a while. They may burn for millions, even billions of years. But eventually, even the brightest light reaches the end of its fuel. When that happens, a star begins to change. It slows, it swells, it sighs, if stars could sigh, and starts to unravel into something entirely new. Because in space, endings aren't really endings, they're transformations. When a star nears its death, the balance it's held for so long begins to falter. Gravity starts to win, pulling everything inward. The fusion that once pushed back begins to fade. Imagine a great orchestra that's been playing for eons, and one by one, the instruments go quiet. What remains is tension, silence, and then release. For a small star, like our sun will one day be, that release is gentle. It expands into a red giant, vast, swollen, and luminous. Its outer layers drift into space, forming delicate shells of gas. Astronomers call them planetary nebulae, though they have nothing to do with planets at all. In the center, what's left is a tiny glowing heart, a white dwarf. It's about the size of Earth, but it carries nearly half the mass of the Sun. Dense, silent, brilliant. It no longer burns, but it still shines from leftover heat. A ghost of the star that once was. A reminder that warmth can linger long after fire fades. For larger stars, the story ends differently, more dramatic, more violent. When a giant star runs out of fuel, it collapses so fast that the core slams inward at incredible speed. Temperatures rise beyond imagination. And, in an instant, faster than a heartbeat, the star detonates in a supernova. The explosion outshines entire galaxies. For a few moments, a single dying star can be brighter than everything around it combined. And then, from that fury, something new is born. A supernova isn't destruction, it's creation through chaos. That blast scatters heavy elements, gold, iron, oxygen, across space. Those atoms drift, mix with gas and dust, and one day, gather again into new stars, new planets, new possibilities. Every mountain, every ocean, every living being, all carry pieces of those ancient deaths. Every breath you take contains atoms that once belonged to a star that exploded long before Earth existed. You are the afterglow of long-lost suns. Sometimes the collapse doesn't end with an explosion. Sometimes gravity keeps pulling, tighter and tighter, until the matter can no longer resist. When that happens, a star becomes something even stranger. If the remaining core is dense enough, the atoms themselves collapse. Protons and electrons fuse into neutrons, creating a neutron star. It's unimaginably compact. A teaspoon of it would weigh more than 1 billion tons, and yet, it spins. Some neutron stars rotate dozens of times every second, their magnetic field sweeping through space, sending out pulses of energy. We call them pulsars. From a distance, they blink like beacons, the heartbeat of a dead star echoing through eternity. But if the collapsing star is larger still, the fall doesn't stop at all. Gravity becomes absolute. Light itself can't escape. And what remains is a black hole, the ultimate silence, a point where the rules of the universe blur and bend, a place where even time loses meaning. It sounds terrifying, and yet it's beautiful. Because even a black hole, the quietest of all objects, helps shape galaxies. Its gravity keeps stars in motion. It sculpts the spiral arms of cosmic structures. It is the dark heart around which light still dances. Even in its death, a star continues to guide the living. That's the secret of the universe. Nothing is ever truly lost. The elements scattered by supernovae become clouds. Those clouds become new stars. Those stars, in time, give birth to planets and life. And when those new stars die, the pattern begins again. It's the same cosmic rhythm, playing forever. Creation, collapse, rebirth. If you could see it sped up, a galaxy pulsing over billions of years, it would look like breathing. Inhale, stars are born. Exhale, stars die. And between those breaths, new worlds emerge. Our own sun will have its turn someday, though not for a long while yet. 5 billion years from now, it will swell into a red giant. It will shed its outer layers into the darkness, and the Earth will be gone by then. But even then, the atoms that once made you, me, and everything we know will still exist. They'll drift into space, join new clouds, and one day become part of something else. Maybe another world, maybe another being, maybe another star. And in that way, you will live again. Not as you are now, but as light, scattered and reassembled into new stories. There's comfort in that, isn't there? Knowing that even destruction has a purpose, that endings in the cosmic sense are just transitions. The death of a star is never quiet tragedy. It's an act of giving. The universe takes the ashes of what once was and turns them into the seeds of what will be. Everything you've ever loved, every breath you've taken, exists because a star once gave itself to the dark. So, if you find yourself afraid of endings, remember the stars. They've died countless times, only to light the way for new beginnings. Maybe life works the same way. Maybe we all do. Pause. And somewhere, right now, a star is dying. Its light, though, will travel for millions of years before it fades from our sky. Long after it's gone, we will still see its glow, a memory made visible. That's what rebirth looks like in the language of the cosmos. When a star dies, its story doesn't end. The light remains, the warmth lingers, and what's left behind becomes something quieter, something patient, like the last glowing coals of a fire that once roared. These are the ghosts of light. White dwarfs, pulsars, magnetars, the echoes of stars that burned long ago, still whispering across the universe. If you could stand near one of them, not too close, of course, you'd see a world of contradiction. Cold, yet radiant. Dead, yet alive in memory. Still, yet spinning faster than thought. Each is a remnant of what came before, a monument to balance lost and beauty transformed. Let's begin with the white dwarfs, the quiet ones. After a small or medium-sized star has spent all its fuel, it sheds its outer layers into space. What remains is its heart, a dense, hot core about the size of Earth. It no longer burns through fusion, no longer creates new light, and yet it glows. For billions of years, it shines from the leftover heat of what it once was, a fading ember in the vast, cold night. Imagine holding in your hand a diamond the size of the planet, shining, pure, nearly unbreakable. That's not far from what a white dwarf truly is, carbon and oxygen, compressed into a crystal lattice under impossible pressure. Over time, it will cool and dim, eventually becoming what astronomers call a black dwarf, a star gone completely quiet. But the universe isn't old enough yet for any to exist. Every white dwarf that's ever formed is still glowing somewhere out there, faint but unforgotten. And then there are the pulsars. If white dwarfs are the embers of the universe, pulsars are the ticking clocks. They are born from collapse. When a massive star explodes as a supernova and leaves behind a dense spinning core made mostly of neutrons. A neutron star. This core can spin hundreds of times per second. As it spins, beams of radiation sweep out from its magnetic poles. And if those beams happen to cross our planet, we see them as pulses, rhythmic, precise, like the beat of a metronome, flash, flash, flash. Each pulse is so regular, scientists once thought they might be signals from alien civilizations. The first pulsar ever discovered was even labeled LGM1. It stood for Little Green Men. But the truth was far more profound. These were the dying heartbeats of stars, a cosmic rhythm that could keep time more accurately than any clock on Earth. Some pulsars are stranger still. When their magnetic fields become unimaginably strong, 1,000 trillion times more powerful than Earth's. We call them magnetars. These are the magnetic monsters of the cosmos. A single magnetar could erase every hard drive on Earth from half the distance to the moon. And yet, for all their power, they are fleeting. Their energy burns out quickly. Their light fades. Their surfaces crack with starquakes, immense tremors that release bursts of X-rays and gamma rays across the galaxy. Each quake is like a sigh from a being too powerful to exist peacefully. A reminder that even the universe's ghosts still have their storms. When you look at the night sky, the light you see might not be alive. It might come from a star long gone, its photons still crossing the void, carrying the last message it ever sent. Starlight is memory, and those memories travel forever. It's possible that somewhere on the other side of the galaxy, a civilization is looking toward our sun right now. Not as it is, but as it was thousands of years ago. They'd see us young, bright, full of potential, because that's how light works. It freezes a moment in time and lets it live on. In a way, that's what white dwarfs and pulsars are too. Frozen moments. They no longer create energy, yet they remain. They keep spinning, they keep glowing, they keep whispering their stories through the dark. And though their voices are faint, the universe listens. Radio telescopes on Earth can hear the pulse of these dead stars, steady, rhythmic, almost musical. Some pulse every few seconds, others hundreds of times each second. If you were to translate their rhythm into sound, it would be hauntingly beautiful, a slow, cosmic heartbeat echoing across the silence of space. White dwarfs fade, pulsars spin, magnetars flare. All are variations on a theme, light finding new ways to exist, even when fuel runs out. It's as if the universe can't bear to let go completely. Even after death, it finds a way to keep shining. That's the secret in these ghosts. Persistence. Not through fire, but through memory. Even when stars die, they refuse to stop telling their stories. And when we study them, when we trace their signals and measure their flickers, we're doing something quietly poetic. We're listening to the afterlife of the cosmos. We're tuning into the echoes of creation itself. It's almost like listening to the last notes of a symphony, still fading, still resonating, long after the orchestra has left the stage. The sound may be gone, but the feeling remains. If you could float out there, far from the noise of planets and people, you might find one of these ghosts of light. It would be small, dense, silent, no warmth, no breath, no motion visible to your eyes. And yet, beneath that stillness, it would be alive with memory, spinning, humming, glowing faintly, keeping time for the universe. You'd feel it, more than see it, the quiet persistence of something that refuses to fade entirely. That's what makes these remnants so beautiful. They're not grand or dramatic like their former selves. They're the quiet ones, the ones who stay behind, glowing softly long after the party's over. In that way, they're not so different from us. We too leave behind traces, a word, a song, a memory, something that keeps shining, even when we're gone. Perhaps that's all light really is, remembrance made visible. Pause. So, the next time you look up at the stars, remember, not all of them are alive. Some are ghosts, silent, faithful, still shining from a time long before we were here. And maybe one day our sun will join them, a soft echo in the endless dark, keeping quiet company with the other ghosts of light. When a star dies, its story doesn't end. The light remains, the warmth lingers, and what's left behind becomes something quieter, something patient, like the last glowing coals of a fire that once roared. These are the ghosts of light. White dwarfs, pulsars, magnetars, the echoes of stars that burned long ago, still whispering across the universe. If you could stand near one of them, not too close, of course, you'd see a world of contradiction. Cold, yet radiant. Dead, yet alive in memory. Still, yet spinning faster than thought. Each is a remnant of what came before, a monument to balance lost and beauty transformed. Let's begin with the white dwarfs, the quiet ones. After a small or medium-sized star has spent all its fuel, it sheds its outer layers into space. What remains is its heart, a dense, hot core about the size of Earth. It no longer burns through fusion, no longer creates new light, and yet it glows. For billions of years, it shines from the leftover heat of what it once was, a fading ember in the vast cold night. Imagine holding in your hand a diamond the size of the planet, shining, pure, nearly unbreakable. That's not far from what a white dwarf truly is, carbon and oxygen, compressed into a crystal lattice under impossible pressure. Over time, it will cool and dim, eventually becoming what astronomers call a black dwarf, a star gone completely quiet. But the universe isn't old enough yet for any to exist. Every white dwarf that's ever formed is still glowing somewhere out there, faint but unforgotten. And then there are the pulsars. If white dwarfs are the embers of the universe, pulsars are the ticking clocks. They are born from collapse. When a massive star explodes as a supernova and leaves behind a dense spinning core made mostly of neutrons. A neutron star. This core can spin hundreds of times per second. As it spins, beams of radiation sweep out from its magnetic poles. And if those beams happen to cross our planet, we see them as pulses, rhythmic, precise, like the beat of a metronome, flash, flash, flash. Each pulse is so regular, scientists once thought they might be signals from alien civilizations. The first pulsar ever discovered was even labeled LGM1. It stood for Little Green Men. But the truth was far more profound. These were the dying heartbeats of stars, a cosmic rhythm that could keep time more accurately than any clock on Earth. Some pulsars are stranger still. When their magnetic fields become unimaginably strong, 1,000 trillion times more powerful than Earth's. We call them magnetars. These are the magnetic monsters of the cosmos. A single magnetar could erase every hard drive on Earth from half the distance to the moon. And yet, for all their power, they are fleeting. Their energy burns out quickly. Their light fades. Their surfaces crack with starquakes, immense tremors that release bursts of X-rays and gamma rays across the galaxy. Each quake is like a sigh from a being too powerful to exist peacefully. A reminder that even the universe's ghosts still have their storms. When you look at the night sky, the light you see might not be alive. It might come from a star long gone, its photons still crossing the void, carrying the last message it ever sent. Starlight is memory, and those memories travel forever. It's possible that somewhere, on the other side of the galaxy, a civilization is looking toward our sun right now. Not as it is, but as it was thousands of years ago. They'd see us young, bright, full of potential. Because that's how light works. It freezes a moment in time and lets it live on. In a way, that's what white dwarfs and pulsars are too. Frozen moments. They no longer create energy, yet they remain. They keep spinning. They keep glowing. They keep whispering their stories through the dark. And though their voices are faint, the universe listens. Radio telescopes on Earth can hear the pulse of these dead stars, steady, rhythmic, almost musical. Some pulse every few seconds, others hundreds of times each second. If you were to translate their rhythm into sound, it would be hauntingly beautiful, a slow, cosmic heartbeat echoing across the silence of space. White dwarfs fade, pulsars spin, magnetars flare. All are variations on a theme, light finding new ways to exist, even when fuel runs out. It's as if the universe can't bear to let go completely. Even after death, it finds a way to keep shining. That's the secret in these ghosts. Persistence. Not through fire, but through memory. Even when stars die, they refuse to stop telling their stories. And when we study them, when we trace their signals and measure their flickers, we're doing something quietly poetic. We're listening to the afterlife of the cosmos. We're tuning into the echoes of creation itself. It's almost like listening to the last notes of a symphony, still fading, still resonating, long after the orchestra has left the stage. The sound may be gone, but the feeling remains. If you could float out there, far from the noise of planets and people, you might find one of these ghosts of light. It would be small, dense, silent. No warmth, no breath, no motion visible to your eyes. And yet, beneath that stillness, it would be alive with memory, spinning, humming, glowing faintly, keeping time for the universe. You'd feel it, more than see it, the quiet persistence of something that refuses to fade entirely. That's what makes these remnants so beautiful. They're not grand or dramatic like their former selves. They're the quiet ones. The ones who stay behind, glowing softly long after the party's over. In that way, they're not so different from us. We too leave behind traces, a word, a song, a memory. Something that keeps shining, even when we're gone. Perhaps that's all light really is, remembrance made visible. Pause. So, the next time you look up at the stars, remember, not all of them are alive. Some are ghosts, silent, faithful, still shining from a time long before we were here. And maybe one day our sun will join them, a soft echo in the endless dark, keeping quiet company with the other ghosts of light. Not every star burns like a beacon. Most of them, almost all of them in fact, live quietly. They are small, faint, and slow. You could pass a lifetime beneath their light and never notice them. These are the red dwarfs, the humble ones, the keepers of time, the quiet stars. If the giant blue stars are fireworks, red dwarfs are the candles left glowing long after the celebration ends. They are cool by stellar standards, glowing a deep orange or soft crimson, their light gentle rather than fierce. They make up about 3/4 of all the stars in the Milky Way, and yet most are too dim to see without a telescope. But invisibility is their strength. They burn slowly, steadily, with almost perfect efficiency. A red dwarf can live for 10 trillion years, more than 700 times the current age of the universe. They are patience given the form, tiny furnaces that never hurry. If you could visit one, the sky around it would feel intimate. No blinding glare, no scorching heat. Its light would fall gently, like the last glow of sunset that never ends. Planets orbiting such stars sit close, tucked within the warmth like children near a hearth. A single orbit might take just a few days. Seasons would pass quickly, the sky always dominated by that deep, soft ember of a sun. And because these stars are so stable, their planets could, in theory, host life for longer than any other worlds in the cosmos. Perhaps somewhere, a civilization might rise beneath a red dwarf's glow, evolving slowly, with no rush, in a system that never knows true night or true dawn. Inside, the physics of a red dwarf are different. Larger stars burn their fuel in layers, with wild turbulence near the surface. Red dwarfs mix themselves constantly, circulating hydrogen and helium from the core to the surface and back again. Nothing is wasted. They are cosmic recyclers, turning every atom of fuel into light with perfect thrift. Their fusion burns at lower temperatures, but it never stops. No storms, no flares large enough to tear them apart. Just the slow, steady heartbeat of fusion, pulsing through eons. It's strange to think that the universe will one day belong entirely to them. When the bright stars are gone, when the last blue giants explode, and the yellow suns like ours fade into white dwarfs, the red dwarfs will still be there, billions of them, glowing softly through the endless dark. They will become the keepers of the cosmic night, shining long after everything else has cooled. In the far future, when galaxies grow dim, their light will be the last trace of warmth, the universe's final lullaby. Astronomers have already found worlds orbiting red dwarfs. Some are rocky, Earth-sized, sitting in what we call the habitable zone, the distance where water could exist as a liquid. Names like Proxima Centauri b, TRAPPIST-1e, LHS1140b. Cold strings of letters and numbers that might one day become the first true addresses of life beyond Earth. If we ever travel to those worlds, our skies will turn red, our shadows will stretch longer, and night will feel eternal, painted in the color of embers. The red dwarfs teach something simple, that slowness can be strength, that endurance can be beauty. In a universe that celebrates explosions and brilliance, they choose consistency instead. They don't dominate the sky, but they fill it. They don't burn brightest, but they burn the longest. Even the universe itself will run out of fuel before they do. Imagine the distant future, trillions of years from now. Galaxies faded, black holes quiet. Only a few scattered red dwarfs still glowing, their light dim but steady. A traveler drifting through that far future cosmos might see one and think, this is what forever looks like. And around those ancient suns, maybe tiny planets will still orbit. And maybe life will still stir, slow and quiet as it stars. The last stories told in the universe may be whispered beneath red light. So, tonight, while we still live in the age of brilliant skies, remember that most of the cosmos is built on patience. The loudest stars are rare, the quiet ones endure. Their message is simple. Lasting light doesn't have to be bright, it just has to keep shining. Pause. The next time you step outside and see the faintest flicker near the horizon, think of the red dwarfs, invisible to the naked eye, yet countless beyond measure. They are the heartbeat beneath the music, the quiet note that holds the song together. When everything else fades, they'll still be there, small, calm, unhurried, keeping time for the universe. Out there, in the deep dark of the galaxy, stars rarely travel alone. They are not the solitary wanderers we often imagine. Most of them are born together, bound by gravity and motion, dancing partners in a quiet, endless waltz. Space, for all its silence, is full of companionship. When a star is born, it usually has siblings, sometimes a few, sometimes dozens, all emerging from the same swirling cloud of dust and gas. They form together, like pearls strung along a thread, sharing their first light in the same nursery. Some stay together for life, orbiting each other in slow, perfect harmony. Others drift apart over time, scattered by gravity's subtle pushes and pulls. But in their early days, stars are family. And that bond leaves a trace that lasts forever. The simplest partnerships are binary stars, two suns locked in orbit around each other. They come in every kind of pair, one bright, one dim, one hot, one cool, one large, one small. Each star tugs gently at the other, curving space itself into a shared loop. From a distance, it's beautiful, a cosmic duet played in perfect time. Sometimes they orbit so closely that they almost touch, their gases mingling into a glowing bridge of light. Other times, they circle far apart, each taking centuries to complete a single orbit. But no matter the distance, they are connected, each one shaping the other's destiny. Imagine standing on a planet that orbits two suns. At sunrise, two circles of light crest the horizon. The shadows would overlap, the sky painted in gold and crimson. And at sunset, the light would fade in layers, one sun dipping first, the other lingering behind. For any life that might exist on such a world, night would be rare, and twilight would last forever. There are systems even more complex, triple stars, quadruple stars, whole clusters of siblings all bound together. Their orbits weave intricate patterns, a slow-motion ballet measured not in days, but in centuries. Some merge over time, forming massive new stars that flare brightly for a brief, glorious moment. Others tear each other apart, flinging fragments into the dark, scattering seeds for new generations of worlds. Even destruction in the cosmic web creates new beauty. Beyond these intimate dances, there are vast gatherings, star clusters, shimmering groups that hang like jewels in the sky. Open clusters, like the Pleiades or the Hyades, are loose gatherings of young stars, still glowing with the warmth of their birth. Globular clusters, by contrast, are ancient. Tens of thousands of stars packed so tightly that their light blends into one golden haze. These clusters orbit galaxies like satellites, carrying within them the history of the universe's earliest times. Each one is a kind of cosmic archive, billions of years old, yet still singing softly through space. If you could drift through one of these clusters, it would feel like floating through a sea of fireflies. Everywhere you looked, there'd be light. Thousands of suns closer together than the nearest star to our own. The night would never be dark. Every horizon would shimmer, every shadow would glow. And yet, in that brilliance, the same rule holds true: balance. Gravity binds them, but only gently. Too much motion and the cluster unravels, too little and it collapses. Even in the densest places in space, harmony decides who stays and who drifts away. It's not just poetic, it's physical. Stars exchange mass, they trade energy. Sometimes one star even feeds on another, drawing matter from its companion through invisible streams. Astronomers call it accretion. Nature might call it intimacy. In some systems, the smaller star orbits so close that its outer layers spill into the gravity of the larger one. Gas spirals inward, glowing as it falls, a luminous thread between them. From afar, it looks like love. Up close, it's survival. Even galaxies themselves follow the same pattern. Each one is a web of billions of stars, all moving together in spirals and streams, bound by the unseen pull of gravity. If you could zoom out far enough, you'd see that even galaxies aren't alone. They gather into clusters, which form filaments, which stretch across the universe like veins of light through a body too vast to imagine. The structure of everything, from atoms to galaxies, follows the same design: connection, balance, shared motion. The universe is not a collection of lonely points, it's a web. There's a quiet comfort in that, because even in the coldest corners of space, nothing is ever truly isolated. Every star pulls on another. Every orbit leaves its mark. It's the same for us. We're made of the same matter, obeying the same subtle laws, drawn to one another by invisible threads, shaping each other's lives in ways we may never fully understand. The physics of companionship is written into the universe itself. So, when you look up tonight, remember, those stars you see are not just scattered lights. Many of them are pairs or families or clusters dancing together in slow time. They've been orbiting one another since before the first human looked up to wonder what they were, and they will still be circling long after we are gone. The night sky is not still. It's alive with motion and relationship, a tapestry of connection woven from gravity and light. And maybe that's the quiet lesson hidden in the stars, that togetherness, even across impossible distance, is part of what keeps the universe in balance. No star truly shines alone. Every star you've ever seen, every sunrise you've ever known, began in darkness. Not the kind of darkness that means absence, but the kind that waits, heavy, warm, and full of possibility. This is where light begins, in clouds of dust and gas adrift in the deep, places we call nebulae. They are the nurseries of the cosmos, the cradles where gravity whispers, "Come closer," and chaos answers with the first sparks of creation. If you could float inside one, you wouldn't see sharp outlines or bright stars. You'd drift through colors that shift like smoke, violets, blues, and soft golds, light filtering through clouds so vast they could swallow solar systems. A nebula can stretch for hundreds of light years. It's not solid, it's not quiet, it's a living fog, cold, dense, and restless. Inside, atoms collide gently at first, then faster, drawn together by gravity's steady hand. Over millions of years, they gather, swirl, and compress until, deep within the cloud, the first tiny core begins to glow. A protostar, the faintest heartbeat of light. In these first moments, it's not bright enough to shine through the dust around it. It's hidden, like an ember beneath ash. You wouldn't see it, you'd feel it, warmth blooming in a sea of cold. The gas keeps collapsing inward, feeding that ember, until pressure and temperature rise high enough to ignite nuclear fusion. And in that instant, a star is born. It's one of the quietest miracles in the universe, the moment when gravity and heat shake hands and agree to make light. Every nebula holds countless such stories. Some fade before they begin. Others ignite into great clusters that will one day fill the sky. The Orion Nebula, visible from Earth as a small blur beneath Orion's belt, is one of the most famous. To the naked eye, it looks faint, almost invisible. But through a telescope, it reveals a cathedral of light. Immense pillars of gas and dust, glowing pink and gold, with hundreds of newborn stars tucked inside. Each one of those tiny points will one day have its own system of planets, moons, comets, and maybe, just maybe, life. The light that reaches us tonight from Orion began its journey about 1,300 years ago, but the stars themselves have been shining for only a few million. Children by cosmic standards. Nebulae aren't always gentle. Some are shaped by violence, the aftermath of dying stars that exploded and flung their ashes into space. Those ashes become raw material for the next generation of suns. In that way, every nebula is both a graveyard and a nursery, death and birth sharing the same space. It's the universe's way of recycling its brilliance. If you listen closely, in that half-imagined way we listen to silence, you might hear a kind of rhythm, gravity pulling, gas swirling, fusion beginning. A slow pulse, steady and patient. Astronomers have mapped these motions using radio waves and infrared light. They can see where a star is forming, even when it's hidden behind curtains of dust. They can trace the flow of matter as it spirals inward, marking the invisible hand of creation. And yet, even with all our instruments, there's still something deeply mysterious about it, because every new star feels like an act of hope, light emerging from the very thing that once blocked it. Some of the most famous nebulae carry poetic names, as if even scientists couldn't resist the wonder. The Eagle Nebula, home to the towering pillars of creation. The Carina Nebula, where giant stars sculpt clouds into luminous waves. The Lagoon, the Trifid, the Rosette. Each one tells the same story in different colors. That creation is messy, beautiful, and unstoppable. If you were to drift past one of these stellar nurseries, you'd see pockets of heat glowing faintly through the dust. Each pocket, a potential sun. Each sun, a potential world. Around them, disks of gas begin to spin. Protoplanetary disks, From those swirling rings, planets take shape grain by grain, like snowflakes forming in slow motion. It can take millions of years for those worlds to solidify, and billions for them to host life. But the first step, that tiny flicker of fusion, begins here, in these clouds that look like dreams. Our own sun was born in such a place about 4.6 billion years ago. It likely formed alongside hundreds of sibling stars, all from the same nebular cloud. Most of those siblings are gone now, scattered across the galaxy. Some may still shine, some may have gone dark, and somewhere, perhaps, one of them still glows faintly, unaware that a small world once formed beside it and learned to wonder. There's something poetic about that, isn't there? The idea that our sun had a family, a cluster that drifted apart long before humanity ever existed. We are, in a sense, cosmic orphans, tracing the memory of our origins back to those ancient clouds. And when we look at the Orion Nebula, or the Eagle, or the Veil, we're looking not just at distant space, but at our own beginning, the birthplace of everything we know. Pause. If you close your eyes now, you can imagine it. A field of glowing dust stretching forever. The slow motion of creation, the soft light of a newborn star breaking through the mist. No noise, no rush. Just gravity doing what it has always done, gathering, warming, giving birth to light. So, when you see a star tonight, remember, it came from darkness. It began as a whisper in the dust, and from that whisper came everything. The warmth on your skin, the glow in the sky, the spark in your cells. That's how the universe begins again, endlessly. Light born from shadow, silence giving way to song. Most stars live in families, clusters, pairs, or quiet neighborhoods of light. But some drift alone, no orbit, no companion, no home. They wander the dark between worlds, solitary suns cast out from the places where they were born. Astronomers call them rogue stars, but the name doesn't quite capture their poetry, because there's something haunting and strangely beautiful about a star with no sky. Imagine a sun that once belonged to a system, circling peacefully among its siblings, lighting planets and moons, until one day, a gravitational accident changed everything. Perhaps another star passed too close. Perhaps a supernova's shockwave swept through, and in that cosmic turbulence, the star was flung away, pulled free of its family's gravity, set adrift into the dark. Now, it travels the galaxy alone, crossing hundreds of light years in silence. No planets orbit it. No dawn or dusk greets it. It shines only for itself, and for no one to see. A light with no audience, a warmth that never touches a world. We don't often think about stars this way, as travelers. But the universe is restless. Every star moves, even the ones that seem still in our sky. Some dance together, others drift apart, and a few are hurled into exile, flung at unimaginable speed across the void. Some of these wanderers are racing faster than any planet or comet ever could, fast enough to one day leave the Milky Way entirely, forever alone between galaxies. We call them hypervelocity stars. They are the exiles of the cosmos, still burning, still alive, but beyond any home we can name. If you could follow one, it would be a lonely journey. No constellations, no familiar patterns. Just a single star gliding through darkness so deep it has no reference, no up or down. Its light would still shine for billions of years, spreading into an emptiness that will never reflect it back. And yet, it shines anyway. That's the most remarkable thing. Even without worlds to warm, even without eyes to see, it still burns. Because that's what stars do. They shine, not for applause, but because that is their nature. And maybe that's a kind of wisdom too. To do what you were born to do, even when no one is watching. To keep glowing, even when the darkness doesn't answer back. It's easy to think of these wanderers as tragic, but perhaps they are simply free. They are not bound by gravity's leash. They have no orbits to repeat, no fixed paths to trace. They drift where they please, carrying their light into corners of space untouched by any other. In their solitude, they write the edges of the universe. Sometimes rogue stars carry ghosts of their past, the fragments of worlds that once orbited them. a planet or two flung into the dark with their parent sun, still clinging to its faint warmth. Imagine that, a world wandering through interstellar night, no neighboring stars, no familiar sky, just the glow of its lonely sun, smaller than a coin held at arm's length. On such a planet, there would be no sunrise or sunset, only a constant twilight. The light would never change. The stars, if any were visible at all, would remain fixed forever. A quiet that no human has ever known. A stillness that lasts for eternity. Astronomers suspect there may be billions of these rogue worlds and stars, drifting unseen. Some were thrown out of their galaxies long ago. Others were born in isolation, never part of any system at all, born free. And yet, they are not lost. Because even motion without destination is still part of the universe's great pattern. Every wanderer, every drifting sun, still obeys the same laws of gravity, the same pull of time. Even their loneliness is connected to everything else. There's a quiet metaphor hidden there. We too sometimes drift, between places, between moments, between certainties. We lose our orbits, our patterns, our sense of belonging. But like the stars, we don't stop shining. We carry our warmth with us, even when no one can see it. We move through the dark not to escape, but to continue. The light we give doesn't depend on where we are, only on what we are. Pause. If you could watch one of these wanderers pass through the galaxy, it would look like a single slow-moving ember floating through infinite black. And for millions of years, it would remain unchanged, still glowing, still alone, still beautiful. No one knows where they end up. Perhaps they drift into the dark spaces between galaxies. Perhaps they collide with another system one day and join a new family of stars. In the universe, even loneliness isn't permanent. Every exile carries the potential to belong again. That's the quiet truth behind the wanderers. They remind us that light doesn't need an audience. That purpose can exist without witness. A rogue star doesn't stop shining when it's cast adrift. If anything, its light becomes purer, a private flame moving through infinite dark. And maybe, in some quiet way, the universe needs that. Not every star can stay home. Some must roam to spread the glow a little farther. So, as you drift towards sleep, think of them. The wanderers, the outcasts, the solitary suns. Their paths are long, their skies empty, their futures uncertain. And yet, they burn, softly, steadily, without end. Their light may never reach another world, but it still exists. And in that existence, there's beauty. Every world, every ocean, every mountain you've ever known was sculpted by starlight. Long before Earth cooled, before water pooled, before the first breath of life rose into the air, a star was already shaping what would become home. Stars don't just shine, they create. They are builders, sculptors, and storytellers. Every atom, every color, every living thing traces its lineage back to the light of a star. When a star forms, it doesn't remain quiet for long. Even as it settles into balance, it breathes energy outward, a steady wind of charged particles streaming through space. We call it stellar wind. It's invisible, but powerful. It can strip gas from planets, carve out gaps in dust clouds, and shape the very architecture of a solar system. In the early days of a young sun, that wind blows hard, fierce enough to sweep away the leftover fog of its birth. What remains becomes the building blocks of worlds. Dust clumps into pebbles, pebbles merge into boulders, boulders gather into planets. And just like that, a family of worlds begins to orbit their parent star, drawn in, yet kept at the perfect distance by its gravity. If you look at our solar system, you can still see the fingerprints of that stellar wind. The inner planets, Mercury, Venus, Earth, Mars, are rocky, stripped bare. The outer giants, Jupiter, Saturn, Uranus, Neptune, are swollen with gas, spared by distance. All of it decided by the breath of the sun, billions of years ago. That ancient wind, long gone now, determined everything from your planet's atmosphere to the color of your sky. We are, quite literally, shaped by the sun's first exhale. But stars influence more than orbits. They sculpt chemistry itself. Inside their cores, fusion builds elements one by one, layer by layer. Hydrogen into helium, helium into carbon, carbon into oxygen. Each new element is a step in a long chain of creation, leading eventually to the material of life. When the biggest stars die and explode, they scatter those elements across the galaxy. Iron, calcium, nitrogen, the raw materials for everything from mountain stone to muscle fiber. When you look at your hands, you're seeing stardust organized into the shape of curiosity. When you breathe, you exchange atoms once part of stars long dead. The air itself is a gift from ancient light. Even after their deaths, stars continue to shape worlds. The shock waves from supernovae compress nearby clouds, sparking new star formation. The debris becomes the seeds for new planets, and those planets in turn will one day give rise to life that looks up and wonders where it all came from. In that sense, creation never stops. Each generation of stars builds the next. Every explosion is both an ending and a beginning. It's not destruction, it's inheritance. Here on Earth, the sun's touch still defines everything. It paints the seasons, drives the winds, stirs the oceans, and fuels the growth of every blade of grass. Without the sun, Earth would be a frozen stone in the dark. With it, we have everything we know as life. Every leaf that turns light into energy through photosynthesis is practicing an ancient art, the art of absorbing a star's fire and turning it into something gentle. When you eat, you are eating sunlight transformed by time and biology. When you walk outside and feel warmth on your skin, you're feeling photons that began their journey in the sun's core 100,000 years ago. They spent millennia bouncing, scattering, ricocheting through dense plasma before finally escaping into space and finding you. Every warm touch from the sun is a survivor of that long journey. The power of stars goes even deeper. Their gravity organizes galaxies. Their radiation sets the chemistry of planets. Their light decides which worlds can thrive and which will freeze. A star's color determines the mood of its solar system. A blue star burns hot and bright, but briefly, flooding its planets with fierce ultraviolet light. Too much for life, as we know it. A red dwarf glows softly for trillions of years, offering long stability, but less warmth. Our yellow sun sits in the middle, calm and steady, a balance that makes oceans possible and time generous. We live, quite literally, in a golden interval. Some stars do more than just nurture. They sculpt beauty on a galactic scale. When a massive star's wind blows through surrounding gas, it creates glowing bubbles, like lanterns hanging in the dark. When multiple stars form together, their winds intertwine, creating filigree patterns of light across the sky. We see these in nebulae, the delicate arcs, the lace-like webs, the glowing edges where light meets shadow. Every curve, every shimmer is the fingerprint of starlight on matter. The universe is full of their artistry, and yet, for all their power, stars are fragile in their own way. They rely on perfect balance, gravity pulling inward, fusion pushing outward. Too little pressure, and the light fades. Too much, and the star tears itself apart. It's the same tension that defines life itself, creation balanced against collapse. Perhaps that's why we find them so beautiful, because in their light, we recognize something familiar, the struggle to hold steady in an unpredictable universe. Pause. Look up tonight, and you'll see that story written across the sky. Each point of light is a memory of creation. Each flicker, a reminder that your atoms were once inside something vast enough to sculpt galaxies. The calcium in your bones, the iron in your blood, the gold on your finger, all were forged in the heart of a star that lived, burned, and died long before the Earth was even dust. You are, in every measurable way, the child of stellar fire. And just like the stars that shaped you, you too leave traces. Every word, every gesture, every kindness ripples outward, changing the world in ways you'll never fully see. The light you give doesn't end with you. It travels, passed on, reflected, absorbed, and remembered. Because that's how the universe works. Light creates light. Warmth gives birth to warmth. And somewhere, far away, another small star begins to glow, because one before it dared to shine. The universe has no clocks, no ticking hands, no bells to mark the hours, and yet, It keeps time. Through light, through rhythm, through the slow breathing of stars. Every flicker, every pulse, every whisper of radiation drifting across the dark is part of that ancient metronome. The cosmos doesn't count seconds. It counts moments of light. If you could listen to the universe instead of looking at it, you'd hear time as music, a symphony of repeating signals, each star, each planet, each orbit, keeping its own rhythm. Some stars pulse like slow heartbeats, expanding and contracting every few days. Others flicker hundreds of times a second, their light spinning like a lighthouse beam. Each one is a note in the great harmony of cosmic time. Astronomers call them variable stars, suns whose brightness changes in regular cycles. And by studying those cycles, we've learned how to measure the distances between galaxies, how to map the shape of the cosmos itself. Light becomes a ruler, rhythm becomes a calendar. A star's heartbeat becomes the measure of eternity. The most famous of these are the Cepheid variables. Their brightness rises and falls with clockwork precision. The longer the period, the brighter the star. By comparing those cycles, astronomers realized they could measure the scale of the universe. The first accurate distances to other galaxies came from the gentle blinking of these faraway suns. You could say that every second we understand about cosmic history, every age, every eon, is written in the pulse of light. The stars were keeping time long before we knew what time meant. Further out, in the realm of the dead stars, another kind of clock ticks even more perfectly. The pulsars, neutron stars spinning at incredible speeds, send out beams of radiation like rotating lighthouses. Each pulse is precise, not almost precise, perfectly precise. Some pulsars spin hundreds of times per second, and their timing drifts less in a year than the best atomic clocks ever built by humans. They are the true timekeepers of the universe, steady, eternal, unfaltering. If you could translate their signals into sound, it would be a heartbeat too perfect to belong to anything living. Click, 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 forever. These stellar clocks let us test the laws of physics themselves. By measuring how their pulses bend around massive objects, scientists confirm the effects of gravity, even detect ripples in space-time. Gravitational waves, time, space, and light, all woven together in the rhythm of these silent, distant machines. And it's humbling to realize that our entire sense of cosmic history, the age of stars, the birth of galaxies, the length of eternity, depends on listening carefully enough to light. But stars don't just measure time, they make it. Because time, as we experience it, is defined by change, by the movement of one thing against another. And nothing moves, nothing changes without the stars. They burn their fuel, shift their colors, expand, contract, collapse. Each stage marks an era, a milestone, a breath in the life of the cosmos. From their rhythms, we name epochs, the time of formation, the age of fire, the twilight of light. The universe doesn't know minutes or years. It knows brightness and decay, birth and silence. It's strange to think that even our own human clocks, the way we track seconds and days, are echoes of the sky. Ancient people learned to tell time by the sun's rising and setting, by the movement of stars across the night, by the tilt of shadows, the phases of the moon, the slow march of constellations through the seasons. Before there were machines, there was light. Before there were hours, there were orbits. Every watch, every calendar, every time zone on Earth is just a reflection of that one simple truth. The stars move, and we follow. Some stars flicker unpredictably, a shimmer here, a dimming there. But even that chaos is useful. Astronomers can read those changes to measure a star's age, its size, its temperature, even its mood. The universe hides its story in the smallest variations. A wobble in brightness becomes a signature, a fingerprint of time, and we, tiny, fragile creatures orbiting a single star, learn to decode it, to turn light into language, and language into memory. Pause. When you look up tonight, remember, every star you see is older than any number you can imagine. Its light began long before there were calendars, before there were oceans, before there was thought. By the time that light reaches you, it's already a history lesson. You're seeing the star not as it is, but as it was. Look at Sirius, and you're looking 8 years into the past. Look at Betelgeuse, and you're looking 600. Look at distant galaxies, and you're looking millions, even billions of years backward. Every glance at the sky is a journey through time. And somewhere, across the darkness, another civilization, if they exist, might be looking at our sun right now, seeing it as it was in the days of the first humans. To them, our world might still be wild and new, our fires still young, our lights just beginning to glow. In that way, time becomes relative not just to physics, but to perspective. Every beam of light carries a different now. The sky above you is not the present. It's a gallery of moments, preserved in starlight. The stars are timekeepers, but they are also archivists. They remember. Every flicker, every pulse, every photon that ever left a star is still traveling, still carrying the record of its birth. And one day, when the universe grows cold and quiet, those last faint traces of light will still be moving, carrying time itself across the dark. Because even when the clocks stop, even when the suns fade, the memory of time doesn't die. It just keeps traveling, forever. Soft pause. So, as you lie beneath the stars tonight, let their rhythms settle into you. Let the pulse of the universe slow your own. Because in this vast, ancient cosmos, you too are part of its heartbeat. One more flicker in the long, steady ticking of time. And somewhere out there, in the silence between the stars, the universe is keeping perfect time, with you. When we look up at the night sky, it feels eternal. The same stars, the same patterns, the same quiet canvas that ancient people once saw and named. But the truth is gentler and stranger. The sky is not fixed. It moves, it drifts, it changes, slowly enough that no single lifetime can feel it, yet fast enough that eternity itself rearranges. The heavens, like everything else, are alive. Thousands of years ago, when the first storytellers stood under the same stars, they saw something familiar, but not identical. The North Star wasn't the same one we follow today. The constellations sat in slightly different places, and even the tilt of the Earth pointed somewhere else entirely. The sky, it turns out, is a slow-moving ocean, and we, on our little island of a planet, are drifting through it, changing our view one wave at a time. This motion has a name: precession. It's the slow wobble of the Earth's axis, like a spinning top that leans in circles. Every 26,000 years or so, the North Pole points toward a new place in the sky. Right now, it's aimed at Polaris, our North Star, our steady anchor in the dark. But 5,000 years ago, the ancient Egyptians built their pyramids beneath a different one, Thuban, in the constellation Draco. And thousands of years from now, our descendants will have another guide, perhaps Vega, bright and blue, sitting where the North once was. Even our compass points aren't permanent. They just move too slowly for us to notice. The stars themselves are shifting too. Each one travels through space on its own path, orbiting the center of the Milky Way at incredible speed. They are like sparks in a grand whirlpool of motion, tracing invisible spirals across millions of years. We call this proper motion, the subtle drift of stars across the sky. To us, they look frozen, but over centuries their patterns change. The constellations we know, Orion, Cassiopeia, the Big Dipper, are temporary. Give them 100,000 years, and they will dissolve into new shapes. Orion's belt will stretch. The Big Dipper's handle will curl. The sky our ancestors knew will become unrecognizable, and yet, it will still be beautiful. Just different. If you could watch time sped up, thousands of years in a heartbeat, you'd see the constellations drift and swirl like glowing sand in a cosmic breeze. Lines would bend, angles would fade, myths would redraw themselves. It would be mesmerizing, a living, breathing sky painting itself anew forever. Humanity has always reached for meaning in these shifting lights. We connected dots and told stories: hunters, queens, dragons, lovers, bears. Each culture saw something different. Each found reflections of its own hopes and fears among the stars. To the Greeks, Orion was the hunter, chasing the Pleiades across the heavens. To the Lakota, those same stars were seven sisters, dancing in a circle of light. To the Maori, they were Matariki, a sign of renewal and harvest. Same stars, different stories, one sky, always changing, yet always ours. It's humbling to think that our myths too will fade, that one day new beings, perhaps on Earth, perhaps somewhere else, will look up and name new constellations in the same sky, now unrecognizable to us. Their stories will rise where ours end. Their symbols will stretch between stars that once spelled Orion or Ursa Major, now scattered into unfamiliar forms. And just like us, they'll think their sky is eternal. But change is not loss, it's memory in motion. The sky doesn't forget. It simply keeps evolving, carrying traces of every age, every navigator, every storyteller, every dream that ever looked upward. When we map the heavens, we are really mapping our own history of wonder. Every myth, every name carved into the constellations is a way of saying, we were here, we looked up, we tried to understand. Even the light we see is a kind of motion. The stars you gaze at tonight are not where they appear. Their light takes time to travel, years, centuries, even millennia. So, when you make a wish on a star, you're really wishing upon the past. That light left before you were born, before your ancestors, perhaps before the first words were spoken. It is the oldest letter in the universe, written in brightness, addressed to whoever happens to be watching when it finally arrives. And tonight, that watcher is you. Pause. If you step outside now, the stars will seem still, steady, perfect. You'll find Orion's belt, the curve of the Dipper, the glow of Vega, faintly blue, like cold fire. And yet, as you breathe, they are already moving. As your heart beats, their distances are changing. As you blink, the shape of the sky rewrites itself, imperceptibly, but certainly. Time doesn't erase the stars. It only teaches them new ways to shine. In a few million years, our sun too will have drifted far from where it began. It will orbit the galaxy's core like everything else, tracing a long, slow spiral through a changing sky. By then, humanity may be gone, or change beyond recognition, but the stars will still move, the universe will still rearrange, and the stories will start again, written by whoever inherits the light. So, when you look up tonight, remember, you are part of a living sky. The constellations you see are snapshots of a moving tapestry, one frame in a film that spans eternity. You're standing inside the story, between the past and the future, watching time unfold above you in points of light. It may look still, but it isn't. The stars are drifting, the sky is changing, and yet, somehow, it always feels like home. One day, the stars will go out. Not suddenly, not all at once. It will happen softly, like a candle burning down, like the last embers of a fire fading in the quiet of dawn. That's how the universe will end. Not in chaos, but in calm. Not with noise, but with silence. Billions of years from now, long after the last human thought has faded, the bright blue and yellow stars we see today will be gone. The giants will have burned themselves to ash. The suns like ours will have swollen and cooled, leaving behind only faint white embers. The red dwarfs, those patient quiet ones, will keep glowing the longest. Their light will stretch across trillions of years, holding out against the dark. But even they cannot shine forever. One by one, they too will fade. Their warmth will wane, and the universe will dim. The galaxies, once brilliant spirals of light, will drift farther apart. Space itself will keep expanding, faster and faster, pulling the islands of stars beyond one another's reach. Even light will struggle to cross those growing distances. The night sky will no longer be filled with constellations. There will be no Milky Way, no Orion, no memory of the patterns we once knew. A future observer, if any remain, will look up and see only darkness, their own lonely star, floating in an infinite black ocean. And in that moment, the universe will feel empty. But emptiness is only what remains when creation rests. It's strange to imagine an end so peaceful. No explosion, no collapse, just quiet. Physicists call it heat death. The point when energy is spread so evenly that nothing more can happen. No more stars, no more warmth, no more time as we know it. Everything slows to stillness. Every particle drifts apart, farther and farther, until motion itself forgets what it was. The universe, once a symphony of light, becomes a single held note fading into silence. And yet, even that silence has its grace, because every atom, every photon, every trace of light that ever existed will still exist, scattered thinly through infinite space. The record of everything that ever was written across the dark. Light never truly disappears. It stretches, cools, softens, but it remains. Even in the coldest possible night, something of what we are will still be there, faint but eternal. In that far future, the remnants of stars, white dwarfs, neutron stars, black holes, will be the last keepers of warmth. They will drift through the darkness like memories, holding the final heat of creation. A white dwarf cooling to black, a neutron star pulsing one last time, a black hole swallowing the last wandering photon. And then, even the black holes will fade, evaporating slowly through Hawking radiation, dissolving back into the fabric of space. The final lights of the cosmos will not explode. They will simply fade away. But if you listen closely, even in imagination, you might hear something softer hidden beneath that ending. A possibility, a whisper. Because endings, as the stars have taught us, are never absolute. Every death in the universe has given birth to something new. The ashes of old stars became the elements of life. The collisions of galaxies made new worlds. And perhaps, in that last quiet darkness, new physics might emerge. New beginnings hidden in the quietest corners of existence. Maybe the universe will breathe again. Maybe light will return, in another form, under another set of laws. Maybe even silence is just a long pause between songs. For now, though, we live in the bright middle of the story, the age of light. The universe still glows with billions of suns, galaxies still bloom, and the night sky, though ancient, is still full of life. It's easy to take that for granted, this brief window of brilliance between two eternities of darkness. But it's a privilege to exist during the time when stars still shine, to look up and see not nothing, but everything, to be alive while the universe still remembers how to glow. One day, even memory itself will fade, but tonight, the light is still here, the stars are still singing in their quiet, endless way. Their voices travel through time and distance, carrying warmth to anyone who will listen. And if you close your eyes now, you can almost hear it, that low hum of energy that fills all of space, the leftover echo of creation itself. It's the sound of existence continuing, softly, the heartbeat of the cosmos, still steady, still alive. And maybe that's all eternity really is. Not infinite years, not endless activity, but persistence. The quiet refusal to disappear. Every beam of starlight, every atom of dust, every thought that ever wondered about the sky, they all leave an imprint. The stars shaped the worlds, and the worlds shaped us. And when the stars are gone, we will still be part of their story, scattered through the dark, shining faintly in memory. Because even when the light goes out, its echo remains. Always. So, as you drift towards sleep, think of that far future, not with fear, but with calm. The universe isn't ending. It's resting. It's simply folding itself into silence, waiting for the next dawn. And until that day, we have the stars, still shining, still teaching us how to let go, gracefully and without hurry. The journey is ending now. The stars are still above you, quiet, patient, unchanged. But the story has circled back home. Tonight, you've drifted through galaxies and ages, through light and shadow, through the lives and deaths of suns. You've seen how they are born, how they live, and how they fade. And somehow, through all of it, one truth remains constant. You are part of them. You always were. Long before your name, before your first breath, before the oceans that cradled the earliest life, a star lived and died to make you possible. The iron in your blood was once forged in its heart. The calcium in your bones was shaped by its heat. The carbon that carries your thoughts was released in its final sigh. Every atom you are was made in a furnace that no longer exists, billions of years away in both space and time. And yet, here you are, breathing, listening, alive beneath the glow of the same kind of light that first created you. It's easy to forget how profound that is. To overlook that, you are, in every sense, the universe remembering itself. When you touch the earth, you're touching stardust cooled into stone. When you drink water, you're swallowing molecules older than the sun. When you look into someone's eyes, you're seeing a reflection of the same physics that governs the birth of stars. You are not small. You are vast in ways that can't be measured. Every heartbeat, every thought, every dream is a spark continuing the story that began in the first fire of the cosmos. The light didn't end there. It became you. There's something deeply comforting in that, because it means nothing is truly lost. Not the light of a star, not the life of a planet, not the warmth of a single human soul. Everything continues, transformed. Just as the ashes of dying suns became your world, so too will the traces of your life ripple outward. Tiny, invisible, eternal. Every laugh, every kindness, every quiet moment of love. They move through others, through time, like soft waves of light spreading across the dark. We are transmitters of starlight, all of us. Even when we forget it, the stars taught us how to live, how to burn with purpose, how to balance, how to let go. They shine not because they seek meaning, but because shining is what they are. And maybe that's our purpose too, not to search endlessly for significance, but to exist fully, to give warmth, to share light, to burn gently while we can. Because one day, like them, we will fade, but the glow we've shared, the things we've built, the love we've given, the stories we've told, those will travel on. They will outlive us, echoing quietly in others, just like starlight echoing through the void. That's how the universe remembers. Look up, just once more, before you rest. See that faint shimmer above the horizon? That's the light of a star that died before humans ever walked the earth. And yet, its glow is still here, reaching you now, in this moment, across billions of years. That's how long light can last. That's how long memory can travel. So, when you feel small or alone, remember that you are made of the same endurance. You are light that refuses to fade. Tonight, the stars are not just distant fires. They are family. They are history. They are you. You come from them. You return to them. And in between, you carry their brilliance in your own small, shining way. The same physics that holds galaxies together holds your heart in rhythm. The same gravity that shaped worlds keeps your feet against the ground. The same energy that sparked the first atoms flows quietly through every living thing. You don't have to look up to belong to the stars. You already do. If you close your eyes now, the light doesn't vanish. It simply moves inward, into your thoughts, your breath, your quiet pulse. That is starlight too. You've spent this whole journey moving through time and space, tracing the origins of existence. And now you've arrived at the simplest truth. You are not apart from the universe. You are what the universe feels like when it finally looks at itself and smiles. That's all you ever needed to be. A spark aware of its own fire. Gentle pause. So let go now. Let the day soften. Let the mind rest. You don't need to reach for the stars anymore. They're already within you. Their story is your story. Their calm, their endurance, their quiet persistence. It's yours too. Every breath you take is a continuation of the oldest rhythm in existence. Light expanding, cooling, and becoming new life again. And when you sleep, the stars will keep their watch. They always do. If you'd like to drift with them again, come back. There are still so many constellations to visit, so many stories to tell. But for now, just rest. The stars will still be here tomorrow, and so will you, part of them, and always shining in return. So, sleep now, child of starlight. The universe is still humming softly. Everything you are is safe. Everything you love still glows somewhere, quietly, patiently, eternally. You are made of what endures. You are made of stars.